A fleeing celestial body. NASA recently spotted a mysterious entity moving through space at a staggering speed of 1.6 million kilometers per hour. The object is moving so fast that it could escape the gravitational pull of the Milky Way and fly into intergalactic space. But what exactly is this Expedient Gonzalez of the galaxy? How can a celestial body reach such a crazy speed? And how was it discovered? Have you heard of NASA's Patio World project? This project aims to search for both unknown brown dwarfs and stars near the Sun in the outskirts of the solar system, as well as the hypothetical Planet 9, which may be hidden in the far depths of the Kuiper Belt. But what kind of academic background is required to join this galactic hunt? Well, none. Patio World is a citizen science project funded by NASA, but primarily managed by volunteers. These volunteers don't need prior knowledge in astronomy, but must prove that they've participated in a tutorial and are interested in spotting fascinating objects added to the star maps. Discoveries made by amateurs are in no way overshadowed by those of professionals. Launched in February 2017, it took only 4 months for community research to achieve a significant success in the form of a brown dwarf located 111 light-years away. A brief overview. Brown dwarfs are celestial bodies that occupy a position between stars and planets. These objects have a mass lower than 75 Jupiters, meaning they cannot initiate hydrogen fusion within their cores. However, they are heavy enough to fuse deuterium. We now know that brown dwarfs are quite rare in space. Members of the Patio World project have succeeded in spotting over 4,000 of these celestial bodies, and one amateur astronomer even discovered the oldest and coldest known white dwarf, which also had a disk of dust. But today, members of Patio World have made an even more extraordinary discovery, quite literally a fast one. As NASA announced last year, we now know of an object in the Milky Way moving at the incredible speed of 1.6 million kilometers per hour. But what allows it to reach such insane speeds? And how do we track such a fast celestial body? An astonishing discovery. The first clue to this cosmic blitzer came during NASA's Wide Field Infrared Survey Explorer (WISE) mission, launched in 2010. The mission was reactivated in 2013 under the name NEOWISE and ended on August 8, 2024. The WISE images were eventually brought to the attention of Martin Kabitnik, Thomas Piepbecker, and Dan Kazalden, longtime members of Patio Universe. These amateur astronomers had noticed a bright object moving rapidly, designated as SAWISE J1249. Kabitnik, who lives in Nuremberg, had a hard time believing what he was seeing on the WISE images from NASA. As he said, "I can't describe the excitement I felt when I first saw the speed at which it was moving. I was convinced it had already been reported, but as we now know, it had not." After NASA received the observations from the Patio Universe community, further observations from multiple ground-based telescopes confirmed the exciting discovery. Thus, the citizen scientists became co-authors of an official study published in the Astrophysical Journal Letters. As mentioned, this object, with its staggering speed, is also flying out of our galaxy. But it's not just its speed that makes SAWISE J1249 special. Its mass is so low that it's complicated to classify it among known celestial objects. Without reliable facts, researchers must turn to theoretical possibilities. It's conceivable that we're dealing with a low-mass star, provided that it doesn't constantly fuse hydrogen in its core. It could also be classified as a brown dwarf. If that's the case, this celestial body would become an astronomical exception. Indeed, we don't know of any other brown dwarf on the verge of leaving its home galaxy. If the object doesn't crash into a star as it travels through space, data from the Keck Observatory has revealed that it contains much less iron and other metals than expected for stars and brown dwarfs. According to NASA, this finding suggests that the celestial body is exceptionally old. It might even belong to the first generation of stars in the Milky Way. Why is the object so fast? Experts can only speculate. One hypothesis is that SAWISE J1249 was once part of a binary star system with a white dwarf. At some point, the white dwarf may have extracted so much material from its companion that it exploded in a cosmic explosion, literally flinging its stellar companion away. Another theory suggests that Expedient Gonzalez was originally in a star cluster, possibly a globular cluster, and that a chance encounter with several black holes, may have caused its rapid and unexpected plunge into the depths of space. In this scenario, it's conceivable that the complex dynamics of this three-body interaction could have catapulted a star out of the globular cluster. Ultimately, it is up to experts to determine which of these two possibilities is more likely. To do this, they will soon examine Sawy's J1249 more closely, hoping to determine with certainty what turned this mysterious object into a cosmic bullet, the fastest star in the Milky Way. Given its speed, the question arises, can it go faster? The answer is yes, and significantly so. Indeed, while Sawy's J1249 travels at 440 kilometers per second, it's just a slowpoke compared to the star S4711. Incredible but true. The fastest star at the center of the Milky Way is moving at a crazy speed of 24,000 kilometers per second, about 86.4 million kilometers per hour. This compares to 8% of the speed of light. If this star can reach such a speed, it's because of its special position as the fastest known star in the Milky Way. S4711 orbits our supermassive black hole Sagittarius A*, and it takes just 7.6 years for this speed marvel to complete a full orbit around this massive object. The discovery of S4711 is attributed to the research team led by Florian Dad of the University of Cologne. They painstakingly analyzed observational data from 2 spectrographs of the extremely large telescope at the European Southern Observatory (ESO) and tracked the orbits and speeds of several faint stars. Scientists had already identified S2, an exceptionally bright star near our central black hole. While S2 was used to verify Einstein's predictions about gravitational redshift and Schwarzschild precession, it has also become the fastest known star in our galaxy. While S2 takes 15.6 years to complete its orbit, S4711 does this feat more than twice as fast. However, the new record holder does not maintain its high speed constantly. Its average orbital speed is about 0.5% of the speed of light, but it only reaches its maximum speed of nearly 8% when it's near the black hole. Scientists suspect that it could be a squeezered, a type of star that has only existed theoretically. These stars orbit their supermassive black hole on highly eccentric orbits, becoming superheated by the black hole's tidal forces when they get close before cooling off again. New in the distance, ghostly examinations have shown that the thermometer of S4711 climbs to 10,000 Kelvin, or 9,700 degrees Celsius. For comparison, the temperature at the surface of the Sun is about 5,772 Kelvin, or 5,500 degrees Celsius. However, researchers also assume that the strength powers of Mare also cause extreme radiation blasts in such stars. If S4711 is confirmed as a squeeze star through further observations, it will be the first known object to move this hypothetical class of stars from theory to reality. At the same time, the discovery of S4711 and 4 other faint stars at the center of the Milky Way also indicates that an entire population of previously undiscovered stars could be hidden in the extreme region around the black hole. Along with stars already detected in what is called Lama S, the orbits of these new discoveries form 2 disks that are nearly side by side, creating a 45 degrees angle relative to the plane of the Milky Way. The reason for this unusual attitude, however, remains as dark as the question of how stars can survive near a black hole without being torn apart by its gravitational forces. During their formation, however, young protostars accompanied by dust cocoons have already been discovered near Sagittarius A*, the black hole at the center of our galaxy. Scientists think it is conceivable that a second, much smaller black hole could be present at the center of the Milky Way. This smaller black hole would counteract the gravitational influence of its larger counterpart, and thus save the stellar birth clouds from destruction. We would like you not to miss any of our videos, so press the thumbs up and subscribe to stay informed. See you soon.